In 1945, botanist Geoff Baylis was surveying a remote island when he found a tree that had no business being there. It was growing on a single rock face, out of reach of the goats that had stripped the island's vegetation bare. The tree had 4 trunks, and its leaves resembled caraca. It seemed the species had been saved, but when botanists examined it, it became clear. Saving it was nearly impossible. The tree was female, and no male specimen existed anywhere. New Zealand then began an operation unlike anything attempted before. They were trying to save a species that could not reproduce on its own. Baylis sent samples to Walter Oliver, director of the Auckland Museum. In 1948, Oliver described the tree as a new species and gave it a name, but he got the scientific classification wrong. He placed the tree in the wrong plant group. The reason for the mistake was simple. Baylis had collected only flowers on the island, no fruit. It was the fruit that would have revealed which family the tree actually belonged to. Baylis himself later said he had anticipated this risk even before the expedition. There had simply been too little time and material to collect. The mistake wasn't corrected right away. In 1970, European botanist Schlechter, working only from herbarium specimens, concluded that the Three Kings tree was simply a stray specimen of Pennantia and Lescheri from Norfolk Island. Baylis disagreed. A pressed herbarium sheet does not show leaf thickness, the way leaves curl in sunlight, or flowers emerging from bare old wood rather than branch tips. It was not until 2002, when the genus was fully revised, that it was finally confirmed that this was a distinct species. While this taxonomic dispute dragged on, the central problem remained unchanged. The species turned out to be dioecious. Male and female flowers grow on separate trees. On the entire planet, one individual existed, a female. Baylis himself wrote about it plainly. The tree was solitary and barren. Self-pollination occurred, but nearly all the resulting seed proved sterile. Where had the goat problem come from? In 1889, the government had released 4 goats on the island as emergency food for sailors should a ship wreck on the rocks. Within a few decades, the population had grown 100-fold. By 1900, the island already carried 300 to 400 goats, from 4 individuals, released just 11 years earlier. No predators, no competitors. Just an island of limited size and vegetation that had had no time to adapt to grazing. By the time of Baylis's visit, nearly 50 plant species on the island had vanished locally. Others survived only where the goats couldn't reach, like this tree on a steep, scree slope. Even goats wouldn't risk crossing. The Guinness Book of Records would later list the species as the rarest tree in the world. The Three Kings Islands hold 199 plant species, a significant share of which grow nowhere else on the planet. So the fate of one tree was never just the story of a single plant. It was the story of what would happen to an entire fragile island ecosystem if it was left unprotected. Baylis was the first to act. In his garden in Dunedin, one broken-off sucker took root and grew remarkably similar to the parent tree, with the same 4 slender trunks. But getting cuttings to strike from the canopy proved impossible. Not at the Plant Diseases Division at Mount Albert, nor at the Duncan and Davies Nursery in New Plymouth. Baylis asked the nursery's chief propagator, George Smith, what else could be done. Smith answered curtly, "Cut the tree down." He explained he was confident he could root shoots from the trunk. The only question was whether they would appear at all. The tree had 4 trunks. Baylis cut one. A year later, shoots appeared. A naval vessel Baylis happened to be aboard as a guest was headed straight for New Plymouth, the next port on its route. The cuttings got an express delivery. Smith rooted them and put the species' survival beyond any doubt. The cuttings Smith took propagated an entire generation of clones, genetically identical copies of that single tree on the scree slope. In cultivation, they proved surprisingly hardy. They tolerated wind, drought, and even light frost, despite being accustomed at home only to ocean storms. But the hardiness of a mature tree and the capacity to reproduce are 2 different qualities. The first came quickly. The second remained unsolved for decades. The following 30 years proved slow and grinding. Rooting hardwood cuttings took up to 10 months. Young plants often died in their first year. 50 years had passed since the discovery, and the species remained a rarity in cultivation. Baylis himself wrote in 1997, precisely because of its dioicy and the single existing female. He died in 2003. Colleagues continued tending the trees grown from those cuttings. One such tree was maturing in Auckland. Ross Beaver, a microbiologist by primary specialty, regularly walked past it on his lunchtime strolls. He watched it bloom with white flowers, then watched them wither, with no fruit at all. At 16, Beaver had rediscovered a rare orchid previously known only from a single tattered herbarium specimen, a plant later named in his honor. He had been the top biology student in the country, even in school, and the knowledge of nature he gained before university would carry through his entire career. Before Beaver, others had already tried solving the problem a different way. Crossing the mainland, species Kaikomako, Pennantia corymbosa, with the lone female baylisiana. The hybrids proved viable. One was later named Otari debut and still grows in Wellington's Botanic Garden today. But a hybrid is no longer the species Baylis had found. That meant reproduction through loss, not through preservation. Beaver took a different path. His specialty was plant fungal diseases, not the propagation of rare species. But the gap between flowering and total infertility wouldn't let him go. It echoed what had happened 35 years earlier with Baylis himself. One person finds a rare plant, another finds a way to propagate it. In Baylis's case, that second person was the propagator Smith. In Beaver's case, it was nursery owner Davidson. In 1985, Beaver began experimenting with the tree at the research center at Mount Albert. The species' pollen was typically sterile. This wasn't his first or only approach. Before settling on a working combination, he tried various ways to concentrate the tree's resources, water, and nutrients onto a single flower cluster. Only after several failed attempts did he find the solution: a weak herbicide solution that mimics natural plant hormones, weak enough not to harm the tree, but capable of softening the hard coating of the pollen grains. He then transferred pollen by hand from flower to flower on the same tree. It worked. For the first time in its known history, the tree set ripe fruit, purple, less than a centimeter long, each containing one viable seed. 40 years after the tree's discovery on the island, the species had finally gained the capacity to reproduce on its own. Beaver himself later described his interest in the tree simply: he had become interested in the cultivated plant back in the 1980s and treated the female flower clusters with the hormone, hoping for viable seed. He directly suspected that perhaps among the resulting seedlings a single male might turn up. It was with that hope that he gave part of the seedlings to Davidson, so they'd have a better chance of reaching flowering age under varied conditions. But the capacity to reproduce didn't mean a quick result. Every new tree grown from Beaver's seed needed 4 to 5 years before it could flower and fruit on its own. That meant, despite the breakthrough of 1985, the true scale of the species' propagation wouldn't become visible until the early 1990s, once the first seedlings matured. A few years later, in 1989, the same thing happened to the wild tree on the island, with no human intervention at all. It turned out the wild individual was also capable of rare natural self-pollination, but the result remained fragile. Out of the entire seed crop, only one seed in 2000 germinated. One of the seedlings Beaver raised was named Martha. In the early 1990s, Martha began fruiting on her own, with no hand pollination whatsoever. The species had stopped depending on human intervention at every stage of reproduction. This was a turning point in its own right. A tree that for 40 years could not produce a single seed without human help now had an offspring capable of reproducing entirely on its own. Martha became living proof that the species could move beyond a laboratory experiment and become a genuinely self-sustaining population, even if only in pots on the mainland. Beaver and nursery owner Geoff Davidson grew the first 6 seedlings through the 1980s and into the early 1990s. One of the seedlings grew at Davidson's site, directly in a wooden barrel at the nursery in Orashia. A photograph taken in 2007 captured the moment. Davidson stands beside the barrel where Martha grows, by then already a mature tree, fruiting on its own for more than 10 years. Davidson sold trees through his nursery and channeled the proceeds to conservation organizations. He asked buyers to report when their trees flowered. Everyone was waiting for a male specimen, which would finally resolve the reproduction problem. None ever appeared. Davidson later recalled the waiting of those years simply, "Everyone hoped to see a true male. It never happened." And despite thousands of new trees raised in nurseries across the country, none of them changed the central fact. The species remained without a male, just as it had been when Baylis first saw the tree on the scree slope. The Guinness Book of Records itself briefly captured the essence of the problem. The tree found in 1945 exists only as a female specimen and cannot bear fruit. That entry remained in place for decades, even after the tree, thanks to beaver, was already fruiting. The official record simply couldn't keep pace with the speed of the scientific breakthrough. Davidson, despite the absence of a male, never lost hope. He openly dreamed of one day seeing Martha's descendants back on Three Kings, among the very rocks where it all began. Colleagues joked that his dreams had a habit of coming true. Meanwhile, the island itself, under 7 square kilometers in size, was gradually recovering without the goats. But forest recovery didn't mean the tree that had once lived there would automatically return. Every step of its return had to be planned separately, from scratch. The new trees raised by Beaver and Davidson didn't solve the central problem. Hundreds of pots on the mainland weren't enough to protect the species from extinction. For that, wild trees were needed on the island itself. In 2005, Department of Conservation botanist Peter DeLange and ranger Janine Collings took on the task. They developed a protocol for returning seed to the island without risking the introduction of pathogens, particularly Phytophthora, a group of fungi notorious for causing the Irish potato famine of the 1840s. This wasn't an abstract threat. Studying various Phytophthora species and their danger to New Zealand's forests was the work Beaver pursued right up to the final months of his life in 2010. Protecting the island from this exact fungus became part of the scientific legacy he left behind. The researchers cleaned 4,000 seeds grown at Davidson's nursery, packed them into cold storage, and opened the containers only after landing on Manawatawi. DeLange later explained why the protocol was so strict. A single contaminated spade or pair of uncleaned boots could doom an entire range of species found only on this island to rapid extinction. Simply planting seed without screening would have meant risking not just one species, but the entire fragile ecosystem of Three Kings. The team then marked out trial plots across the island to determine where the tree might establish best. They couldn't assume that the shallow soil on the rock face where the wild tree had survived was the optimal habitat for the species. That spot had survived only because the goats couldn't reach it, not because the soil there was best. By 2012, the team had recorded 65 living seedlings on the island. By that point, 500 seeds had already been given to the Ngati Kuri iwi. In 2019, Manaaki Wanua Landcare Research, in partnership with the Canterbury Museum, raised another 200 seedlings and handed them to the same iwi. They were planted around the Waiora Marae in Ngataki, north of Kaitaia. That same year, members of Ngati Kuri independently planted another 80 seedlings on the mainland. Ngati Kuri Executive Director Sheridan Waitai describes the tree as part of the fabric of life for her people. Every species that disappears is a tear in that fabric, in their history and culture. She negotiated a condition with the scientists. Research on iwi land would continue only with full knowledge sharing. Today, Ngati Kuri and the Department of Conservation jointly manage Manawatawi. As of today, the wild tree is still there. One, on a steep scree slope the goats could never reach. It remains the only wild individual of its species on the planet, despite decades of artificial propagation. In cultivation, the picture is entirely different. Trees grow in botanic gardens across New Zealand, at Auckland Botanic Gardens, Wellington Botanic Garden, Otari, and the University of Auckland. Seedlings have taken root on mainland properties and around the Waiora Marae in the north of the country. The Ngati Kuri iwi continues caring for the trees entrusted to them and studying which conditions suit the species best, a step toward the ultimate goal. One day returning the tree not just as seedlings in the ground, but as a living, self-sustaining population on the Three Kings Islands themselves, the place from which it had nearly vanished. The species is still classified under New Zealand's highest threat category, based on a criterion accounting for a population under 250 mature individuals. Formally, this means that even thousands of young trees in cultivation and on the mainland don't change the species' status until a stable, self-sustaining population of mature plants exists on the island. There is also reason for cautious optimism. The species carries a doubled chromosome set compared to its relatives, and botanists estimate that this genetic trait may give it an extra reserve of resilience, despite the fact that every living tree today descends from a single original plant. Every new tree that flowers on its own is another step away from one plant on a rock face toward a species in full. Beaver died in 2010, 9 years before the first trees were given to Ngati Kuri. But the method he found at Mount Albert remains the reason there's anything to hand over today. The tree Baylis found in December 1945 is still there.